Hello, this is Dr. Daystorms, and I'm trying something different this year with the way that I've taught this class or other classes in general in the past, in that I wanted to do some of the lectures at least up front, and then that way we can discuss and do example problems in class itself. And so, welcome to General Chemistry, and here in Chapter 1 we're just going to go over what should be, it's probably review for some of you, in general, but it's a good foundation to start the semester. So this first part of the chapter, we're going to discuss scientific method and classification of matter. So the scientific method is something that you perhaps have addressed in school previously with writing, having like a science fair project, for example. And it's a method that we use. It's a systematic approach to solving our problems using science. And so it starts off in general with making an observation about something from nature, a natural phenomenon. Okay? Then what you do is you look for the patterns, the trends, the laws, things that are universally consistent. Perhaps it's just something that you've noticed over and over again. And then you're going to formulate a hypothesis. You know, that's in elementary school or middle school, they called it the educated guess. But there has to be some type of explanation that tries to explain what you've seen, and it has to be testable. That's important. You have to have some type of test for this, and you formulate your experiment. You repeat this, and you modify your hypothesis as needed based off of the results. So you do this over and over again until you can come up with some type of model. That model, many times, is called a theory. Okay. And then eventually you're going to do additional experiments based off of this model, and then ultimately, if it's irrefutable, it becomes what's called a law of science. And there are very few scientific laws. So, for example, the law of gravity versus, the theory of Darwinian evolution. Okay? So let's look at the example that they give in your textbook. I like this example. Let's see if I can blow it up. I really like this example here because it's one that comes from history. Right? So, for example, it was noticed, back in this last century or so, it was noticed that the milkmaids, like Dutch milkmaids, they milked by hand, and they noticed that these milkmaids didn't contract smallpox like the rest of the population. So it was an observation, something that they thought that they could possibly test. And so what they did is they noticed that many times there's a much more mild pox virus called cowpox, and the milkmaids would contract cowpox early on. And so it was believed that because of this having contracted cowpox, that they had formed a natural immunity to smallpox. And so that was the hypothesis. Okay. So next up, they wanted to look, and they started to develop an experiment for that. And so I know that this sounds astronomically amazing, but they intentionally exposed or gave children this cowpox virus because it is much less virulent, meaning it's not as deadly as smallpox. And so they give healthy children cowpox, essentially. Then later on, they intentionally expose the child to smallpox. Now, because of this, they noticed that the child did not contract smallpox, so there seemed to be some type of natural immunity that resulted from having developed or being exposed to cowpox at a younger age. Okay? So finally, what they did is then they took that and they did further experiments where they deliberately inoculated more humans with the cowpox virus. And lo and behold, this did confirm the model. Ultimately, they were able to come up with a smallpox vaccination through working with cowpox. Let's see. So, what is chemistry? Chemistry, in the simplest terms, is just the study of matter and the changes that the matter undergoes. And so this is a good example here. Taken from another book, in looking at the three phases of water. And so we have water as water in its solid form, which is tightly packed water molecules, and I'll explain that further in a moment. That's evident as an iceberg. We have water in the liquid form, and then we have water in gaseous form. Matter is anything that has mass and takes up space. Many times and I do this just as badly as anyone else, but we erroneously equate mass and weight as the same thing. And if you've taken physics, you'll learn that weight is actually due to the gravity's pull on your mass. And that's the reason why you weigh less on the moon than you would here on Earth, because Earth has a stronger gravitational pull, whereas the moon doesn't. However, on both locations, you have the same amount of mass. So that's the only difference between mass and weight. So for all intents and purposes, many times here in chemistry, we often talk about something that when we take the mass, and we'll talk about something and how much it weighs per se. But technically there is a slight difference. But mass is is anything that has up mass and it takes up space. And so it could be a liquid, it could be a gas, it could be a solid, so on and so forth. If you look at the building blocks of matter, we're talking about the atoms. And the atom is the smallest fundamental unit that you can take of something, whereas if you break it down any further, it no longer has that same identity. We can split the atom, but into its protons and neutrons and electrons and even nuclear particles, subatomic particles. However, it's no longer the oxygen, or it's no longer a molecule of water. Okay, and so therefore, when we talk about atoms, they're the building blocks of matter, but once you split them up, it's lost its identity. So here are just a few examples. We have, diatomic oxygen, which is what's natively found in nature. We have water, which is made up of 2 hydrogen atoms and an oxygen atom. Carbon dioxide. And then you can have larger things. We have acetylsalicylic acid, which is more commonly called aspirin, which is something that you'll focus on and you'll learn about in organic chemistry most likely next year. Every element is made up of the same kind of atom, and so therefore the smallest unit of, say for example, neon that you can get would be a single atom of neon. If you try to break that up anymore, then it's no longer neon. It's broken up into its subatomic particles like protons and neutrons and electrons, and you'll learn more about those later in the semester. A compound is whenever you have 2 or more different kinds of elements put together. Okay, so that's why we have a compound of a molecule of... Whoops, let's go back. We have... Sorry about that. So for example, here we have a compound of a molecule of water. That water is composed of 1 oxygen atom and 2 hydrogen atoms. Matter can have different states based off of how closely bonded the atoms are. If they are loosely bonded to where they can move around a lot, we commonly refer to that as gas. Okay, the gaseous state of matter. If you either cool it off or you add pressure to condense it down, you can force it to become liquid. Or if you further cool it, or add even more pressure, you can make it to be a crystalline solid. Okay, likewise, we can go from a solid to a liquid to a gas, just like you can melt an ice cube to a liquid, and then you can boil liquid water and turn it to steam. So now we're going to talk about the classification of matter. Okay, and so we have matter, and we're going to be able now to break it down and to classify it further. So the first question that we need to ask ourselves is it uniform throughout? And so you have two possibilities here, yes and no. So for example, if it's no, it's called a heterogeneous mixture. Hetero means different. Okay, and so we have an example of that here. So I recently got married this last summer, and as a part of our ceremony, we had unity sand, where I had the blue sand and my wife had the white sand, and we slowly poured it together into a unity container. And so here we have a heterogeneous mixture. It's heterogeneous because it is not uniform throughout. We have parts of it that's white, we have parts of it that are blue, and I could make this a homogeneous mixture by mixing it up really well to where it looks like a light blue throughout. However, my wife would probably kill me if I did that. Just kidding, of course. So that's a heterogeneous mixture because it is not uniform throughout. If we answered yes, it's called homogeneous. Homo is the prefix for same. And so, for example, if we look back at the unity candle example here, we have the two homogeneous sand mixtures in the sense that we have the one that is white that Deborah was using, and then we have the one that was blue that I was using prior. Now, once we mixed them, of course, it went from a homogeneous mixture to a heterogeneous mixture. So, if we go on from the homogeneous mixture, does it have a variable composition? Now, that's a little different. You can have something that's uniform throughout, but it's made up of different things. Okay? So, we have two possibilities here. One possibility is no, and the other possibility is yes. So, if we say yes, it's called a homogeneous mixture. It's a solution. Okay? However, and these would be examples. Okay? So these are just examples of solutions. These are various chromate solutions, I think, and copper solutions. I'm not sure offhand what this one is, but this could be a copper solution. So we have something like copper sulfate that's dissolved in water. We have some of the chromates dissolved in water, and they give off different colors. But this is actually a uniform mixture, so it's a homogeneous solution here, where we have water and dispersed equally amongst the chromates, for example. If we say no, it doesn't have a variable composition, then it's a pure substance. So for example, you could have a block of ice. Pure ice. It's pure substance of ice. Okay? Now we can take it further and say, can this pure substance be separated into simpler substances? Okay? So if it can't, then it's a pure element. For example, if you have a canister containing, this is sodium. It's called sodium lumps. This is sodium metal ion, so it's the same throughout. It's just sodium metal. If it can be separated into simpler substance, it's called a compound. Okay? So for the example here, we have is water. Water is actually a compound. Okay, and so for example, you can take liquid water and do what's called electrolysis, which literally means using electricity to break it apart. And it will break itself apart, if you add enough electricity to it, into what's called diatomic hydrogen and diatomic oxygen. And so now, and they're given off in the form of gas. Hydrogen gas will escape, and oxygen gas will escape into the atmosphere. But that's a compound. We were able to take something and break it into simpler substances, whereas that sodium metal lump, you can just break it off into little tiny pieces of sodium metal, but it's still going to be uniform throughout. It's only going to be elemental sodium is the element. I hope that this has helped explain the scientific method and matter and the classification of matter.